Okay, by sketching a suitable pair of graphs, show that the equation 2 minus x equals to ln x has only one root. Okay, and then verify the calculation that this root lies between 1.4 and 1.7. Show that this root also satisfies the equation x equals to 1/3 4 plus x minus 2 ln x. And then using the iterative formula, find the root correct to 2 dp. Okay, using x1 value as 1.5. Okay, let's do this. Okay, first of all, okay, very basic work that everyone, okay, in P3 should know how does a ln graph looks like. Okay, a ln graph, y equals to ln x. When y equals to 0, okay, 0 equals to ln x, so x equals to e to the power of 0, which is 1. Okay, so x equals to 1, so it has to go through 1. Okay, most of your marking scheme says very clearly whenever you draw a ln x graph, it has to go through 1. If it doesn't go through 1, okay, then it is deemed wrong. Okay, so it's something like that. So that's what ln graph looks like, y equals to ln x. Okay, it has to go through x equals to 1. And then your next graph is, if you look at it, it says 2 minus x and ln x. So when it's equal, meaning meeting, point of intersection, POI. Okay, that's what it means. Okay, so 2 minus x, okay, that's a year 9 skill, so everybody should know. Okay, so it's a line that cuts at 2 and also 2 over here. And then if you draw this line, so it just goes something like that. So we know clearly, if you have drawn this before, your root must be, if you look at the question, it says take x1 as 1.5. So definitely, and even from the sketch, we can see that our x value is somewhere here. Okay, this is the, I'm talking about the x value. Okay, that's where your x value should be. Okay, now part 2. Okay, that's part 1 done. Okay, part 2, verify by calculation, okay, that this root lies between 1.4 and 1.7, 1.4 and 1.7. So 2 minus x equals to ln x. So ln x plus x equals to 2. Okay, so ln x plus x minus 2. Okay, this is the function. So when x equals to 1.4, what is the value? So ln 1.4 plus 1.4 minus 2. Okay, and the answer is negative 0.2635. okay, it's a negative value. Okay, do the same thing when x equals to 1.7, ln 1.7 plus 1.7 minus 2, and the value is positive 0.23063, and that's positive. So as we have done this before, change of sign, okay, change of sign indicates that the graph has traveled from the negative region of function x to positive region, and when it travels, okay, or moves from negative to positive, it has to, the graph cuts the x-axis. Okay, the graph cuts at x-axis, therefore a root must present, okay, here. So part 3, let's look at part 3. Show that this root also satisfies the equation x equals to 1 over 3 4 plus x minus 2 ln x. Okay, let's do that. So x equals to 1 over 3 bracket 4 plus x minus 2 ln x. So rearrange this, so this will give you 3x equals to 4 plus x minus 2 ln x. So 3x minus x minus 4 equals to negative 2 ln x. So 2x minus 4 equals to negative 2 ln x. So divide everything by 2. Okay, divide everything by 2 gives you x minus 2 equals to negative ln x, and divide everything by times by negative 1, or divide by negative 1 should give you negative x positive 2 equals to ln x, which I can rewrite as 2 minus x equals to ln x. Okay. Okay, part 4, iteration. xn plus 1 equals to 1 over 3 4 plus xn minus 2 ln xn. My first x value is 1.5. They've already given. From here we can find what is x2. So just plug in your value. So 4 plus 1.5 minus 2 ln 1.5. Okay, and my first x2 value is 1.5630. Okay, now x3, do the same thing, but this time since we have calculator, just plug in a and s. Okay, type the a and s formula, ASN button, and also a and s here. Okay, and from there we know the answer is 1.5566. And x4, do the same thing again and again until you get few values. Okay, so x4, I've got the answer as 1.5572. x5, I got the answer as 1.5571. x6 equals to 1.5571. and x7 is also 1.55749. Okay, so from here the final answer or final value, iteration value to 2 dp is 1.56. Okay, thank you.